Hi everyone, this video presents on the reaction stoichiometric relations, and the its learning objective is perform stoichiometric calculations involving mass and mole. And I am going to explain you mole relation, mass relation, and mole mass relation, and you will finally have self test activities. And let me explain the mole relation. This is the relation in which you are asked to calculate the number of mole of reactants or products from the given number of moles. And the first, let me explain this with example, calculating the moles of the reactants. Example 1. From this example 1, you are asked to calculate the number of mole of sulfur that react with 1.4 mole of the iron, and the given the balanced chemical reaction is given. And from this we can see that we can use the mole factor. That is, the mole of the iron is 2, the mole of the sulfur is 3. So you are asked to calculate the mole of the sulfur from the given mole of iron. So you can use the ratio of mole of iron to sulfur or sulfur to iron, and we will follow 4 steps. The first step is state the given and the needed. We have given mole and needed, and we'll connect with the mole factor. Step 2 is about the writing a plan to convert the given to the needed. Step 3 is use the coefficient to write the mole factor. The coefficient of iron is 2, the coefficient of sulfur is 2, so you can write the mole ratio, that is mole of iron to the mole of sulfur, or mole of sulfur to the mole of the iron. And step 4 is set up the problem to give the needed quantity, that is 1.42 mole of iron multiplied by the mole of sulfur divided by mole of iron will give us 2.13 mole of sulfur. This is one example. Another example is, the second example is calculating about this one, and it says that how many moles of iodine are required to react with this amount of mole of aluminum according to this chemical reaction, and check whether this chemical reaction is balanced or not. Chemical reaction is already balanced, so you can simply relate this as like this, and write the balanced chemical equation first, and then write the given mole above the element, and then use the mole factor from this balanced chemical equation. It means that to react with 2 mole of the aluminum, it requires 3 mole of iodine. If 3 mole of iodine is required to react with 2 mole of the aluminum from the balanced chemical reaction, and then how many mole of iodine will react with the given one. So the answer will be this one. Finally, after rearranging or using the ratio, the answer is 0.644 mole of iodine will required to react with 0.429 mole of the aluminum. This is mole relation, and calculating the mole of the reactants from the given mole. Another is calculating the moles of the products from the given mole. Example 1, it says that from this chemical reaction, calculate the mole of the product, that is carbon dioxide, that can be obtained or produced from 2.25 mole of the propane. To do this, we will follow again 4 steps. The first step is this one. State the given and the needed. The given one is the mole of propane is given, and we are asked to calculate the mole of carbon dioxide, and we can connect this with mole factor. Step 2 is write a plan to convert the given to the needed, and we have given mole, and then convert this to the needed one. And step 3 is about using coefficient to write the mole factor. Then the coefficient of the propane is 1, the coefficient of the product, the carbon dioxide, is 3. So you can use mole factor in terms of mole of carbon to propane or propane to the carbon dioxide. And step 4, we have to set up the problem to give the needed quantities, and 2.25 mole of the propane times the ratio of the mole factor will give us 6.75 mole of the carbon dioxide. This is example 1, how to calculate the mole of the product from the given mole. Example 2 is, it says that in this balanced chemical equation, and you have given 0.75 mole of the propane, and you are asked to calculate the mole of the carbon dioxide similarly, and the answer will be the 2.25 mole of the carbon dioxide will be produced. This is a way of calculating moles from the given mole. And another is the mass relation. This mass relation is relation in which you are asked to calculate the mass of the product or the reactant from the given mass. Example, calculating the mass of the reactant. Example 1, you are asked to calculate the mass of the reactant oxygen that react with 22.5 gram of the heptane, and check whether this chemical reaction is balanced or not first. And the chemical reaction in this case is already balanced. And step 1 is state the given one and the needed. The given one is gram of the heptane is given, and you are asked to calculate the gram of oxygen, and you can connect with molar mass and mole factor. Step 2 is write a plan to convert the given to the needed. The given one is the gram of the heptane, and the needed one is the gram of the oxygen. And you can go to step 3. Step 3 is use the coefficient to write mole factor with molar mass. The mole factor with heptane with oxygen is this one, or you can reverse this. And furthermore, you can relate the given mole with molar mass and with the given mass. And finally, in the step 4, we set up the problem to give the needed quantities. So 22.5 gram of heptane times the mole factor will give us 79.1 gram of the oxygen. This is one way of calculating the mass of the reactants from the mass of given. And step 2 is, another is calculating the mass of the product from the given one. Example, from this chemical reaction, we have given that 54.6 gram of the acetylene is given, and we are asked to calculate the mass of the carbon dioxide product. And similarly, we can follow 4 steps. The first step is stating the given and the needed. We have given this amount, and we are asked to calculate the gram of the carbon dioxide, and we can relate with molar mass and mole factor. And this chemical reaction, the balanced chemical reaction, is here. Step 2 is write the plan to convert the given to the needed. We have gram of the ethylene, acetylene, and then change this into mole, and then again use the mole factor, and then change the mole by using molar mass to the gram. And step 3 is use the coefficient to write the mole factor. Write the mole factor, that is the mole of the acetylene is 2 from the balanced chemical reaction, and the mole of carbon dioxide is 4. So you can use this ratio or factor, and finally we will have this answer: 185 gram of carbon dioxide will be produced. This is how to calculate the mole of the gram of the product from the given gram of the reactants or the products. Another thing is mole mass relation. In this case, you are asked to calculate the mass from the given mole or the mole from the given mass. Let the substance will be A and B, and then you can by using this relation you can convert the given mass to the mole and use the mole factor. First, from the given, change the given mass of A by using molar mass to the mole of A, and then use mole factor, and then again find the mole of the B, and then after finding the mole, this mole of B can be changed into gram by multiplying or by using the molar mass. This is a way of calculating the mole mass relation. Finally, you have some activities to do. Using one, the first activity is this one. Do this one by yourself. The second activity is, and this one, second activity, third activity, and fourth activity. You have these activities, and finally, in the fifth activity, you have these activities. You can pause this and you can calculate by yourself. So thank you for watching today's lesson. This is all about the relationship of mass, mole, and mole mass. So the next video is the determining empirical and molecular formula. Thank you. Bye bye.